Hello everyone, in this lecture we will learn about and explaining about Kubernetes architecture. So let's get started with the video. So first of all, I'm explaining Kubernetes architecture. That is, Kubernetes follows master slave architecture, and Kubernetes architecture has a master node and the worker node. There are four components of a master node, and that is kube, API server, controller, scheduler, etc. And the worker node has three components, that is kubelet and kubeproxy, container, runtime. So this is how Kubernetes architecture looks like. So this is Kubernetes architecture. So the Kubernetes architecture comprises the following component. First, cluster. So let me explain cluster. A cluster of servers that combine available resources includes RAM, CPU, disk and devices. And next there is a master. So master, a collection of components that make up the control panel of Kubernetes. And next there is it consists of both scheduling and cluster events. So there is a nodes. So let me tell you about the component of master node and worker node in detail. So as I said, a master node manages the Kubernetes cluster, and it is the entry point for all the administrative tasks. You can talk to the master node via the CLI, GUI or API. For achieving fault tolerance, there can be more than one master node in the cluster. When we have more than one master node, there would be high availability mode, and with one leader performing all the operations. All the other master nodes would be the follower of that leader master nodes. So also to manage the cluster stage, Kubernetes uses etcd. All the master node connect to etcd, which is a distributed key value store. As there is a Kubernetes master and there is a controller, etcd, kube, API server, scheduler, as I explained. So there is a pod 1, pod 2 and kubelet, kubeproxy. There is a worker 1 and worker 2. There is also there is a one pod, one second pod, kubelet and kubeproxy. So also to manage cluster stage, kubelets use etcd. As I explained this, all the master node connect to etcd, which distribute the key value store. So there is a Kubernetes master, etcd controller. First there is a controller and it is connected with kube, API server and etcd and as well as scheduler. So I'm explaining this need for controllers, why we need this need for containers, why we need these containers. Why we need these containers? With the ever expanding presence of technology in our lives, downtime or the internet is becoming unacceptable. Hence, developers need to find solutions to maintain and update the infrastructure of the applications. So we need on without interrupting other services people demand on. So the solution is container development. Containers work is isolated environment, making it easy for developer to build and deploy apps. So that's why we need these containers. So let me explain you about all components one by one. So as there is a API server, there is a API server. API server performs all the administrative tasks on the master node. A user sends the REST commands to the API server, which then validates the requests, then process and executes them. etcd saves the resulting state of the cluster as a distributed key value store. So next there is a scheduler. So scheduler, after that we have a scheduler. So as the name suggests, the scheduler schedules the work to different worker nodes. It has the resource usage information for each worker node. The scheduler also consider the quality of server requirements, data locality, and many other such parameters. Then the scheduler schedules the work in terms of pods and services. So next there is a controller manager. So as you can see, this is a controller manager. So non-terminating control loops that regulate the state of the Kubernetes cluster is managed by the control manager. Now each one of these control loops knows about the desired state of the object it manages, and then they look at their current stage through the API servers. So in a control loop, if the desired state does not meet the current state of the object, then the corrective steps are taken by the control loop to bring the current state the same as the desired state. So the controller manager makes sure that your current state is the same as the desired state. So this is a use of controller manager. And then there is a etcd. So the etcd is a distributed key value stored that is used to store the cluster state. So either it has to be a part of the Kubernetes master, or you can configure it externally as well. etcd is written in the Golang, and it is based on the Raft consensus algorithm. So the Raft allows the collection of machines to work as a coherent group that can survive the failure of some of its member. Even if some of the member fail to work, this algorithm can still work at any given time. One of the node in the group will be the master, and the result then will be the followers. Then there can be only one master, and all other master have the follow that master. Then besides storing the cluster state, etcd is also used to store the configuration details such as the subnets and the config map. Next, there is a worker node. A worker node is a virtual or physical server that runs the application and is controlled the master node. The ports are scheduled on the worker node. We have necessary tools to connect them. Ports are nothing but a collection of containers. And they access the application from the external world. You have to connect to the worker node and not the master node. So there is a worker 1 and worker 2. So let's explore the worker node component. There is a container runtime. The container runtime is basically used to run and manage a continuous life cycle on the worker node. Same example of container runtime that I can give you are the container RKT and Galaxy, etc. If it is often observed that Docker is also referred to as container runtime, but to be precise, let me tell you that Docker is a platform that uses containers as the container runtime. Then kubelet is basically an agent that runs on each worker node and communicates with the master node. So if you have 10 worker node, then Kubernetes run on each worker node. It receives the ports definition by various means and run the containers associated with that port. It also makes sure that the container we are part of ports are always healthy. The kubelet contains the container runtime and gRPC framework. So next there is a kubeproxy. Kubeproxy runs on each worker node as the network proxy. It listens to the API server for each server point creations or deletion. For each service part, kubeproxy sets the routine routes so that it can reach to it. So that's all about in my Kubernetes architecture. So I explain all my points of Kubernetes architecture. Hope you like this video and it will be helpful for you. Thanks for watching. Bye.